Hey guys, welcome to the notes for distributive property and like terms. Our essential question is, what is a distributive property? So the distributive property is something that we learn in about middle school, but we do touch on it again in Algebra 1 because we do use it a lot. So let's talk about what distributive property is. I'm going to give you a definition and then kind of like some formulas, and then we'll kind of use it later on. So distributive property. For any number A, B, and C, the product of A and B plus C is, all right, so that was a lot, right? That was a giant definition. But there's product in that definition, so there's something being multiplied, right? So the distributive property is the operation of multiplication. So distributing is multiplying, always. You're always going to be multiplying if you're distributing. So, for example, if I have A times B plus C, I'm going to do A times B like this, and I have AB, and then A times C as well, which is AC. So that's what it means by the product. Oops. Oh no, I think it's too far zoomed in for me to be able to erase anything. So I'll write an A there. Oops. Let me just go ahead and rewrite this. Okay, so A plus C means I have AB plus AC. If I have A times B minus C, that's going to be AB, because A times B, and then A times negative C, so minus AC. So again, this is kind of foreign because it is a bunch of variables. When we get to like actual examples, it'll probably click a little bit better. So, and then if we have negative A times B minus C, that would be negative A times B, which is negative AB. And then negative A times negative C is going to be positive AC, because negative times negative is positive. So those are examples / formulas. All right, term. So what is a term? Well, I've mentioned terms before, but terms are separated. Terms are separated by plus or minus signs. So they're separated by a plus or a minus sign. And I'm going to give you some examples for these. So let's do an example. 5x minus 3. Well, 5x minus 3, okay. Well, I said terms are separated by plus and minus. So there's two things being separated here. I have 5x and I have 3. Two things being separated. So in this case, this would be two terms, because the minus sign is separating the two things. Here's another example. 5x plus 2y minus, actually no, let's do minus 2y plus 3. Okay, how many terms do I have here? I have 3 terms, because I have 5x, and I have 2y, and I have 3. So those are 3 separate things, 3 terms. Okay, so that's what terms are. So really we're just counting how many like groupings we have between minus and plus signs. A like term, so this is important because this is something we use constantly in Algebra 1, or you're going to use it in geometry, any other math class you take after this. So like terms. Terms that have the same variables and exponents. The same exact variables and the same exact exponents. So let's do some examples. 5x and 3x. Are these like terms? Yeah, they're like terms. The reason why they're like terms is because their variable is the same. They both have an x, and the exponents on the x's are the same. So there's technically a 1 exponent on both of these, so they are the same exponent. Let's get another variable. Let's get another example in here. So we have, let's say we have 6y squared and negative 2y squared. right? So variables are the same, they're both y's, and their exponents are the same. So these are also like terms. All right, let's give some examples that are not like terms. 15x and then 3y. Those are not like terms because their variables are not the same. They're not. So they're not like terms. Let's say 3x and 3y. Are these like terms? Nope. Their variables are not the same. I don't care that the number in the front is the same. The variables are not the same, so they're not the same. What about, are these the same? Are these like terms? Yeah, they're like terms. They both have an x, they both have a y, they're like terms. How about now? Are they like terms now? Nope, because y squared and the other one does not have a y squared. But these are like terms because they're exactly the same. So all of your variables need to be the same and all of their exponents need to be exactly the same. Okay, let's talk about what a coefficient is. A coefficient. The coefficient is the number attached to the front of the variables. So you could have one variable, you could have two variables. So let's talk about examples for these. 7x squared. What's the coefficient? The coefficient's the number attached. So the coefficient would be 7. Another example, 16zk. Right, I have two variables, but regardless, what's my coefficient? 16. It's the number attached in front of your variables. So it doesn't matter what is attached to it, the coefficient's the number in the front. So that's some vocab for you. All right, the last vocabulary word we have is constant. The constant is a number by itself. And what I mean by itself, I mean no variables. So let's say a number, by itself without variables. So we're being specific here. So an example, lots of examples of constants, that could be 6 or -3 or 2 or -2700, right? It doesn't matter. Those are all constants because they're all just regular numbers. You could even have a decimal. Whoops, I should have put or here, not a comma. Or 3.5, right? These are all constants because they don't have any variables attached to them. All right, so that's what a constant is, just a regular number by itself. So those are all of the vocab words we have, so that was a bit of time, but now we can actually get into the math of things. Now we're going to name some like terms. Now if I look back at the definition of like term, it's terms that have the same variables and exponents. And if you're not taking notes, you should be. Okay. Same variables and exponents. So a like term with 5x could be 8x, could be 2x, 7x, -3x. As long as it's just the same variables and exponents, it does not matter. So it's a multitude of answers here. You could put whatever you'd like, as long as the variable and exponents are the same. Well, I have 17wz. I could have 38wz. I could have -2wz, -3wz. Right? So all of these are like terms as long as your variables and exponents are exactly the same. Next one, 8x squared y cubed. What's a like term? Maybe 10x squared y cubed, 9x squared y cubed, right? As long as your exponents and variables are the same. So hopefully that has been drilled into your head multiple times and we understand what like terms are. All right, now we're going to combine some like terms and then we'll go into distributing. So combining like terms. Again, what are like terms? They are terms that have the same exact variable and exponent. Same variable and exponent. So let's look at number 1. 3z minus 5x plus 2z. Do I have any like terms? I do. I have 3z and I also have positive 2z. Well, 3z plus 2z is 5z. And then I just have the 5x, the minus 5x from earlier. Now I look, can I combine these two? Are these like terms? No, I can't. These are not like terms. So I just have to leave it as is, and that is my answer. Number 2. Let's actually use red for all these. Okay, do I have any like terms? I have some like terms. I have 7x squared, and I have 4x squared. So these are like terms, same exponent, same variable. 7x squared plus 4x squared is going to give me 11x squared. And then I also have some more like terms. I have negative 3x plus 2x. That's going to be negative 1x, or just negative x. I'll just write negative x. So again, these are all fairly the same thing over and over again. You're just combining like terms. Next one. Let's see if I have any like terms. 17x minus 13xy plus 20xy. Any like terms here? Yes. Negative 3xy and then 20xy are like terms because their variables are exactly the same, and so are their exponents. What about 17x? Does anything match up with 17x? No. So 17x is just going to stay in the front as is, like normal. But now I have negative 13xy plus 20xy. That's going to be a positive 7xy. That's my final answer there. I cannot combine those. They're not like terms, so that's it. All right, now we're going to do some distributive practice. So again, if you're not taking notes, you should be. We're going to start off really easy with a really simple problem. So number 1, we're going to go through 11 problems. So this is the first one. 5 times x plus 2. Okay, distributive property, again, is the operation multiplication. So you're going to be multiplying the entire time. So 5 times x is what? 5x. 5 times 2 is positive 10. I'm done. That's it, right? So 5x and 10 are not like terms, so that is my final answer. Easy enough, hopefully. Now, you're like, well, why do I have to multiply to both? So you have to multiply to every single term inside the parentheses. So I have 2 terms in the parentheses here, so I have to multiply to each of those. Let's move on to number 2. 4x plus 2 times negative 2. Okay, this one's a little bit different because you're like, whoa, another set of parentheses. But, you know, still same process. You always want to distribute the smaller one to the other one. So I'm going to distribute the negative 2 over because that one has less stuff in it. So again, there's 2 terms inside this parentheses, so I need to multiply the negative 2 twice. So negative 2 times 4x is negative 8x. Negative 2 times 2 is negative 4. I can't combine those, so that is my final answer. Negative 8x minus 4. Number 3. Negative 3 times 4x plus 2. I'm probably going to move this one up a little bit. Okay. Same process. How many terms are inside my parentheses? I have 2 inside my parentheses. 1, 2, right? That means I need to distribute 2 times. I'm going to distribute the negative 3 times 4x. So negative 3 times 4 is negative 12x. Negative 3 times 2 is negative 6. And that is my answer because I cannot simplify or combine any like terms. There's no like terms. Number 4. 5x times x plus y. So this one's a little bit different now. We have a variable on the outside. Let's talk about this. You're still going to do the same thing as you've been doing. I have 5x times x. Well, let's talk about that. What is 5x times x? 5x times x, well, I have x times x. And we know that means I have x squared. So I have 5x squared. So 5x times x is going to be 5x squared. 5x times y, I'm going to do that in a different color. 5x times y is going to be 5xy. I just multiply all of them together. I can't combine at all. And that's my final answer. Okay? So those are a little bit tricky because there is a variable on the outside, and we'll get some more practice with that in a little bit here. Okay, let's do the next one. Number 5. We're doing 3x times x cubed plus 5x. Okay, well, same thing as like we were doing earlier, right? 3x times x cubed, because there's 2 terms, I'm going to multiply this twice. So 3x times x cubed. Well, what does that mean? Well, 3x, and then x cubed is x times itself 3 times. So then I have times x times x times x. So the 3x from the outside, and then I have the 3x's here. Okay, well, what does that mean? Well, that means I have a 3, and then I have 4 x's being multiplied together, right? So I have x to the 4th. So 3x to the 4th. It's just kind of like adding your exponent rules, right? We learned this. So x to the 1st times x cubed, I'm going to add the exponents. So it's going to be 1 plus 3, which is 4. And then I have 3x times 5x is going to be 15x squared, because there's technically a 1 here and a 1 here. So x times x is going to be x squared because you add the exponents. And that's your simplified answer because you don't have any like terms. All right. Number 6. Negative 2x squared times x squared minus 4x. All right, well here, same thing as earlier, still distributing. So I have negative 2x squared times x squared. Okay, well, negative 2 times technically a 1 is still negative 2. But then I have x squared times x squared. Well, remember your exponent rules, same base, so I can add my exponents. So it's going to be x to the 4th. Okay, what does that mean? That's negative 2 times x over here. And then I have x times x. So I have 4 x's. Okay. Next, I'm going to do negative 2x squared times, well, negative 2x squared times negative 4x. So negative 2 times negative 4 is positive 8. X squared times x, well, I have 2 x's over here, and I have 1 x over here. So it's going to be 3 x's being multiplied together. All right, go to the next page. Number 7. 3 times x squared plus 4x plus 5. Okay, well, what do I do here? Well, same thing as always, but how many terms are inside your parentheses this time? 3. 1, 2, 3. But it doesn't change the fact that you're still going to distribute 3. So 3 times x squared, 3x squared. 3 times 4x is 12x, positive 12x. 3 times 5 is positive 15. Do I have any like terms? Nope, so I'm done. So the only thing different is that there were more terms, but you still do the same thing like you have been. Number 8. Negative 9 times x squared minus 7x plus 4. Okay, well, I do the same thing I have been doing. Distribute. Negative 9 times x squared is negative 9x squared. Negative 9 times negative 7x is positive 63x, because negative times a negative is a positive. Negative 9 times 4 is going to be negative 36. Again, no like terms, so I leave it as is. Okay, moving on. Number 9. Negative 6x times 2x squared plus 5x minus 9. Okay, well, what do I do here? Well, same thing like you have been. Distribute. Negative 6x times 2x squared. That's going to be negative 12 because negative 6 times 2 is negative 12. Then you have x times x squared, which is x cubed, because you have 1 here and you have 2 there, so you add the exponents. Then you have negative 6x times 5x, so you have negative 30, and then you have x times x, which is just x squared, x here and x here. And then lastly, we have negative 6x times negative 9. That's going to be a positive 54x. And you can't combine any like terms, so this is your simplified expression. Number 10. This one's a little bit different, but not too bad. Negative 10x minus 20 divided by 5. Okay, you're like, whoa, division, what am I doing? So, basically you just have to divide everything by 5. So if you want to, I can write divide. Let me see what my exact words were in class. So let me double check. My exact words in class were divide everything. So let's just divide everything. Negative 10x divided by 5 is negative 2x, because negative 10 divided by 5 is negative 2. What color? Lavender. Okay. And then negative 20 divided by 5 is negative 4. I can't combine like terms, so then I'm done. And that's it. That's all division is. It just looks a little scary, but it's not too bad. And then I'm going to do one more division problem just to show you to get used to that. So number 11, and I'll actually do it right underneath the other one. So let's have in parentheses 36x minus 9 divided by 3. Now, there's parentheses here, right? And earlier when we saw parentheses, we would distribute. Well, what's technically in front of your parentheses right here? A 1. But 1 times anything doesn't change, right? It's itself. So that means my parentheses don't even matter, honestly. So I'm going to continue like normal. Divide everything. 36x divided by 3 is going to be 12x. And then negative 9 divided by 3 is going to be negative 3. And you still have the same thing. So regardless, you treat it the same. You're still simplifying, still combining like terms when you can. So if you have any questions, feel free to ask, but that is it for the notes.